Good afternoon and thank you for being here. My presentation will focus on the Mediterranean area. I'll try to talk about it in terms of vulnerability affecting both terrestrial and transitional ecosystems and also biodiversity. This is just to introduce the structure of my presentation. I'll begin with an introduction to the Mediterranean region and a selection of data showing recent, current and future projections of change. I'll also deal with some specific effects of global warming and anthropogenic pressure on ecosystems. Then I will focus on coastal wetlands as a particular treated area and also a source of ecological and paleoecological information. To this end, I'll present a specific case study from the southern coast of Tuscany, and I'll try to include some references to biodiversity conservation throughout the talk. These ecosystems are located today in 5 regions in the world around the specific latitudinal belts, as you can see here. And they include a variety of vegetation structures that range from the iconic Mediterranean type shrublands to deciduous and evergreen woodlands, evergreen forests, and herblands and grasslands. In these 5 Mediterranean type ecosystems, plants share similar functional traits, resulting in analogous vegetation types, as you can see from these pictures. Among these 5 regions, the Mediterranean basin hosts a very high number of native plant species and also 50% of endemism. And among drivers of this high biodiversity, we have climatic and topographic high heterogeneity, but I want also to highlight another driver, which is fire. This is also a driver for speciation, and it is important in 4 of 5 regions in the Mediterranean basin, where wildfires have a frequency of 30 to 100 years. And so the Mediterranean region is a biogeographical, environmental and historical unit. It is defined through both biogeographical and climatic classification, and it is important to bear in mind that climate dynamics of this region are strongly determined by the Mediterranean Sea and also the Mediterranean chains that surround it. And of course, the high biodiversity numbers we just saw are also the result of a long climatic and geological history, especially climatically unstable periods left a massive imprint on the distribution and abundance of species. For example, in the graph here on the right from Agri-Italy 2020, you can see that last occurrences of both angiosperms and gymnosperm species are linked to major rapid climatic oscillations that occurred between 16 and 12 kiloyears ago. And this pattern is very similar to what is happening today with the ongoing global warming. This means that through the paleoecological studies, we can indeed trace back plant vulnerability in the past, and this can help to improve current conservation actions. Coming back to a more recent time slice, the question is how much has the Mediterranean basin warmed since the pre-industrial period? If we look at these 2 graphs, we see that land areas, so it is the bottom graph, have warmed more than the sea, and if only land areas are considered, The 2020 temperature is 1.8 Celsius degrees warmer than pre-industrial, and it is centered in the 1861-1890 period. And what about the future? Future warming projections over land for the 21st century are highly dependent on the greenhouse gas emissions. As you can see here in these two very different pathways, the red and the blue curves. What is important to highlight is also the warming in the Mediterranean will exceed the global mean value by 20% on an annual basis. And this means that the Mediterranean basin is not only an hotspot of biodiversity, but also an hotspot for climate change. And if we look at the temperature projection for the summer season only, warming rates are highest in summer, particularly for maximum temperatures. And overall, warming in the Mediterranean will exceed the global mean value by 50% in summer. And of course, this will increase the intensity and frequency of heat waves. What about the relationship between global warming and fires? Many authors demonstrate a link between global warming and fires, and in particular summer drought conditions and high temperature are primarily drivers of the interannual variability of fires. And this also demonstrates that large fires are associated with unusually intense heat waves. See these two articles for details. But quantitative evidence from southern France on the left here and from Mediterranean countries on the right show that fires have generally decreased in recent decades. Apart from Portugal, see the red line, which has a contrasting opposite trend, but overall there is a decreasing trend both in terms of burned areas and the number of fires per year. As the authors argue, this is most probably due to the increased efforts in new fire suppressions and prevention in this country. And this approach was able to reshape the fire-weather relationship. And this happened in a context where climate drivers should have led to an opposite trend. This is a good example of what we can do to effectively combat the ongoing fire regime change. And what about future projections? Here in this paper we have the projection of future summer burn areas in the Mediterranean under a 1.5, 2 and 3 Celsius degrees global warming scenarios. The higher the warming level is, the larger is the increase in burn areas, ranging from 40% to 100% across these scenarios. Significant benefits would be obtained if warming were limited to well below 2 Celsius degree. And what can be the effects on Mediterranean terrestrial ecosystems? In this conceptual scheme, we can see that the combined effect of aridity and fires can push the ecosystems to another state. In particular, aridity acts along 3 different axes, decreasing the colonization rate, reducing the resprouting ability after fires, and this can bring about a change of state from Mediterranean woodland to an open shrubland. which is also more prone to fire. What is important here is that very high frequency fires can make these shifts irreversible. The projected increases in aridity may reduce the resilience of Mediterranean forests against fire and drive post-fire ecosystem dynamics towards stable open shrublands. And this would happen especially in landscapes fragmented by human activity. To improve predictions in the future of ecosystem in a changing world in terms of climate and fire regime, it is necessary to consider both global and fine-scale processes. Among global drivers, the increase of dry conditions is the consequence of the global warming, especially related to the summer temperature. The atmospheric increase in carbon dioxide may also contribute to biomass growth, and this is the so-called greening effect, which in turn led to an increase in fuel availability. But this also increased by local factors such as socio-economical changes that have led many people to abandon rural areas. And the first and direct consequence of this process is a sudden increase of plant biomasses and fuel amount. In this framework, other drivers, in this case local drivers, can contribute. For example, the human-induced ignition that led to a shortening of fire return intervals, but also local drought, which is introduced by local dynamics such as the explosive coastal urbanization and the intensive land use. What is important is that in this context, the local policies can make a difference in reducing an overall impact of global warming, and this can be done working on the mitigation of drivers which act at this fine scale and local scale. Human pressure is another important trigger of biodiversity loss and ecosystems degradation. The map on the left here shows the population density of the Mediterranean coastal regions, which is very high and contributes to the increase of landscape fragmentation and pollution focusing. This is happening in a context where urban extent scenarios are projected to further increase, as depicted on the left panels, for several Mediterranean coastal cities. This framework makes coastal areas among the most vulnerable, and this map shows the influx of fertilizers, mainly nitrogen and phosphorus, released especially from industrial discharge and agriculture runoff. This second map shows surface plastic concentrations, microplastic concentration in the Mediterranean surface water, and plastic debris are dominated by millimeter, micrometer, and nanometer side fragments that pose a direct risk to human and marine ecosystems' health. The third map shows concentration distribution of mercury, which is a metal trace element mainly focused along coasts by urban and industrial wastewaters, and also runoff from metal contaminated sites, for example from mining sites. The combined effects of high summer temperature and nutrients released in coastal wetlands and sea simulate photosynthesis and thus primary production, triggering the so-called harmful algal blooms. And in these two maps, before 1980 and between 1980 and 2015, we can see that harmful algal blooms consistently increased their geographical distribution over the Mediterranean Sea. Most of these toxic events are mainly related to the dinoflagellate genera Alexandrium and Dinophysis that are well known to cause dystrophic crisis and also fish death. Now I'm going to continue with the second part of my presentation dealing with coastal wetlands. The Mediterranean coastal wetlands are ecotones transitional ecosystem in close relationship with both terrestrial and marine ecosystems, and they are extremely dynamic environments, and this makes them highly reactive to changes. They are also archives of climatic and environmental history, and in this sense paleoarchives should be preserved in the same way as the other ecosystems and used as an additional tool in conservation policy. For these reasons, coastal lagoons can be considered sentinels of the climate change, both in space and time. As I already said, coastal lagoons are extremely vulnerable, and these ecosystems have been progressively degraded, especially over the last 50 years, as a result of the effects of pollution and global warming, which often act in tandem to reinforce each other, and all these aspects play a part in the environmental degradation. This scheme is useful to summarize all the aspects I just mentioned in this presentation, and we saw that risks and impacts of environmental change in the Mediterranean basin are highly diverse. There are both directly climate-related drivers, increase in temperature, decrease in precipitation during the summer season, or the sea level rise. But there are also non-climate related drivers, such as pollution and urbanization, or an intensive land use. And on these specific aspects, local administration can implement policies and make the difference. So global warming is just one of the many drivers of environmental risk. I would also like to remind you that the effects are not only visible on ecosystems, but also on human health. In this sense, climate change is also an opportunity for a transition to a more sustainable and respectful lifestyle. So thank you for your attention.